So chapter 3, we get into exponentials and logarithms. So we've done this chapter basically in Algebra 2. We'll probably advance it on a couple problems more than before, but really it should be a good review chapter of exponentials and logarithms. So we start out today, we're doing the exponential function, and basically you have to understand what's the difference between 2 to the x and x squared? So the variables in different positions, different locations. So when you look at x squared, the exponent is stuck at 2, and that's really what we call the power family, meaning everything's always raised to the 2 powers, so you plug something in for x, squared, plug it in, squared. So that's the quadratic power family. This is not what we're talking about. The exponential function is where the variable is your exponent. And so as x increases, you're raising a base, in this case base of 2, to a larger and larger and larger and larger power. Now as exponents get larger and larger, right, the number is growing, and it's growing at a fast rate. So if we're going to graph this, x, wherever it says additional points, you can just cross that off. We're really talking about if you need to make an XY table so you could plot some points. So let's say you put in 0. What happens when x is 0? Any base raised to the 0 power is
0.
1. 1. What do you call that when you hit the y-axis? That is the y-intercept. Give me another number to test. Maybe we would go 1. What's 2 to the first power? What's 2 squared? What's 2 cubed? So as you move out to the right, 1, I'd be up at 2. When I go out to 2, I'm up at 4. When I'm out to x is 3, we're at 5, 6, 7, 8. We're up there. So on this side, that's where you see that exponential growth. I'm just continuing the XY table. Now as I move to the negative side, what's going to happen? Somewhere along the lines, you had a teacher that taught you how to work with negative exponents. What happens with 2 to the negative 1? What do you do with the negative exponent? What?
The inverse.
Not the inverse. You're probably thinking the right way, you're just using the wrong terminologies. When you say inverse, what are you talking about doing?
The opposite.
Keep on. What are you going to do to the number then? Let's go that way. What are you going to do? What are you going to write?
1/2.
The reciprocal. So when you have a negative exponent, you write the reciprocal of the base to get rid of the negative exponent. So I can now write 1/2 to the first power. So what's 1/2 to the first power? So I've written the reciprocal of the base, and it gets rid of the negative on our exponent, and 1/2 to the first power is just 1/2. What happens with the negative 2? 2 to the negative 2 is 1/2. What's 1/2 squared? 1/4. Negative 3, or hit math, enter, enter, 1/8. So you can still see like your base of 2 shows up on the bottom of this fraction. 2 to the first, 2 squared, 2 cubed, right? So on this side, as you go 1, 2, 3, we're at a half, we're at a fourth, we're at an eighth. And what is this part of the graph doing? Getting closer and closer to 0. What? It never touches, right?
Yeah.
Because anytime you take your 2, your base of 2, and you flip it, you actually have 1 over something. So it's 1 over 2 to whatever power. No matter how large the denominator becomes, 1 divided by a super large number can never be equal to 0. Does it get close to 0? Yes, it does. So, what's your domain of an exponential function? You can plug in any x you want. I just showed you a bunch of positive numbers, a bunch of negative numbers, and 0. So we can plug anything we want in for x. Range. Do I have any y values down here? No, the graph will not go below 0. Will it touch 0? Doesn't even touch 0. So this is y values that are from 0 to infinity. Now, when you see 0 to infinity, we're talking about the vertical, 0 and up. The horizontal asymptote, the word asymptote in math is talking about long-term behavior or your graph approaches a value. So in this case, when there's a horizontal asymptote, it's going to come down and eventually it looks like it's going to 0. So we just say y equals 0. All exponential graphs look like this. All of them. So know this, exponential functions look like this. Whether it's base 5, base 10, base 2, base 3. Negative x. What's happening with the negative x? What's that going to do to our graph? Flip it which way? A vertical flip or horizontal flip? Because your other choice would be somebody could put a negative in front of the function. So one of these is horizontal, one of them is vertical. Which one are we doing? Horizontal. We're affecting the x, right? So every x you pick, I'm going to flip it to the negative. So anything that was over on the right will end up on the left. Anything that was on the left now flips to the right. And you can make your XY table again. When you plug in 0, what do you get? So, is there such a thing as negative 0? Well, negative 1 times 0 is still 0. So it's 2 to the 0 and you get 1. So it still hits at 0, 1. But now when I plug in 1, 2, and 3, we multiply those by negative 1. So now it's really 2 to the negative 1, which is 1/2, 2 to the negative 2, which is 1/4, and 2 to the negative 3, which is 1/8. So on the positive side, we're coming down against the x-axis. And then if I go negative 1, negative 2, negative 3, 2, 4, 8. So my domain, negative infinity to infinity, range 0 to infinity, horizontal asymptote, y equals 0. So filling in the blanks is identical to what we did on the last graph. The only difference is we have what I would call a horizontal flip. We're flipping over the y-axis, left to right. Exponential graph.